Hey, Algebra 2, welcome back. Here is 13.1b, the second half of our 13.1, and we're going to solve some right triangles. Okay, so this is kind of picking up a little bit on what we did yesterday, or in the previous video, with our trig ratios. Okay, so we're going to find missing sides and angles of right triangles, of A right triangles, of right triangles using trig ratios. It's not a day with Mr. G without a typo somewhere. One day I will go maybe one day without a typo, but we'll see. So we're pretty much gonna kind of use what we learned yesterday to figure some missing pieces of information out from right triangles, right? Because we'll be in plenty of situations where, oops, just open my Windows menu. We'll be in plenty of situations where we don't know all the sides, we don't know all the angles, etc. And so we can use these trig ratios to help us. It's kind of one of the reasons why these are helpful to us. Like what one of the main points behind learning about the 6 trig ratios, right? So it might be helpful to kind of just remind yourself of what the trig ratios are. So I'm gonna scooch up a little bit, and we're just gonna write them down really quick, right? It's kind of like that SOHCAHTOA thing we were talking about yesterday. You know, what is the sine of theta? What is the cosine of theta, etc. That kind of idea. So let's just start there. Let's kind of remind ourselves of that. So remember, sine of theta, that was the opposite side divided by the hypotenuse. The cosine of theta is the adjacent side divided by the hypotenuse. Tangent theta is the opposite side divided by the adjacent side. And then the other 3 trig functions, the cosecant of theta, the secant of theta, and then the cotangent of theta. Remember, those are really nice because those are just reciprocals straight across, right? Cosecant is the reciprocal of sine. So that's just going to be hypotenuse over opposite. Secant is the reciprocal of cosine, so that's going to be hypotenuse over adjacent. And then cotangent is the reciprocal of tangent, adjacent over opposite. Okay, like I said in the 13.1a video, make sure you kind of write this in a place where you'll be able to see very often, maybe like on an index card, on like the front cover of your notebook somewhere, because we'll be using this quite a lot. Okay, so let's just kind of jump into an example and see what we can do with these trig functions and these trig ratios. Solve for x in the triangle below, round to the nearest hundredth whenever necessary. So maybe we'll have to do some rounding at the end here. So we have a couple of pieces of information. We have the length of the hypotenuse. We have one of the angles is actually measuring 30 degrees. And then we want to find the length x of this leg right here. Okay, so we're going to use our trig ratios to help us here. First, what we want to do is we are given an angle. And so that's probably the one we're going to want to use here. We're going to call that one our theta. So theta is going to be 30 degrees in this case. Okay, remember at the end of the day, theta is just an angle. So we might have an actual measurement for it, in this case 30. So if I make this my theta, then that means that this is the opposite side, this is the adjacent side, and this is the hypotenuse. Oops, I'm not doing well with my P's today. These are very, there we go. Okay, so adjacent, hypotenuse, opposite. So we're gonna wanna pick the trig function that kind of works with the information that we're given. We don't know the opposite side at all. We don't have any clue what it could be. So we're probably not gonna wanna use the opposite side in our equation to find x. We're going to want to use a trig ratio, a trig function that involves the adjacent and the hypotenuse side. So let's kind of look back up and see which one that would be. Okay, we're looking for trig functions that involve the adjacent and the hypotenuse. It looks like our 2 candidates are cosine and secant. Okay, so those are the 2 that we're going to kind of choose from. Now, if you have your own scientific calculator or just any calculator in general, you're going to see that we actually don't have a button for secant. We only have a button for cosine. And because of that, solely because of that, we're going to use the cosine because we can put that in our calculator, and we're going to need to here in a few seconds. Okay, so we're going to use cosine. So cosine of theta, but instead of theta, I'm going to write 30 degrees. Cosine of 30 degrees is equal to my adjacent side, x, over my hypotenuse, 8. Okay, cosine of 30 degrees is going to be a number. Okay, it's taking the adjacent side over the hypotenuse, the ratio of that whenever the angle is 30 degrees. Okay, and that's going to be a set ratio because that's just kind of the way it works for a 30-degree angle. Okay, and that's going to be the same case for any angle you put into these trig functions. It's not something we're supposed to know. We're going to plug that into our calculator here in a few seconds. Okay, but before we do, let's just solve. Okay, here to solve for x, I'm going to multiply both sides by 8. So x is equal to 8 cosine of 30 degrees. Or I should say 8 times the cosine of 30 degrees. Okay, you can plug this into your calculator. You're going to want to make sure first, before you do that, that your calculator is in degree mode. And you'll often know it's in degree mode if you're on your scientific calculator, you're going to see DEG somewhere on that display screen. Okay, you might also see instead the radian mode, RAD. If you see RAD, that's a different measurement of angles that we'll talk about in the next section, but we're not using that right now. So you're going to want to make sure you change the mode on your calculator to degrees. And sometimes it's actually either DEG or DRG. Okay, so look for either of those. And if it's not there, you'll need to change the mode. If you have trouble with that, ask for help in class and I can help you to change that, change it to that mode. Okay. We can also use Desmos. Desmos we've been using quite a lot this semester. It helps us for a lot of things, even in terms of trig. So we can use that for this case, just so I can show you. And in case you don't have a calculator at home. So we can do 8, head over to functions. We're already in the trig menu, cosine. And now before you hit enter here, or before you enter in a number, we're gonna go to the little wrench in the top right-hand side in the corner. And we're going to make sure we're in degree mode. So we're going to click on degrees here, make sure we're in degree mode. Now that we are, we're going to go back here and put 30 on the inside of that cosine. Cool. So there is our answer, 6.93. If we're rounding to the nearest hundredth, because that is 2 decimal places. Okay, so our length here is 6.93. And that is our answer for this question. Okay, so notice how we're able to find this length, this x, just by knowing the angle and another side length, right? I was able to find that by using trig ratios. And that's kind of the idea we're going to follow. You're pretty much going to use the sides to determine which trig function to use. And you're pretty much primarily going to want to pick from sine, cosine, and tangent of theta. Okay, pick from these three, okay, because they are in our calculator. Okay, so we're going to primarily pick from these three. Now we can use cosecant, secant, and cotangent, because what I could do is if I wanted to calculate the cosecant of 30 degrees, then that would be the same as doing 1 over the sine of 30 degrees because they're reciprocals, right? But that's a lot more work than maybe using the sine function, okay? And we will have to do this eventually, but for right now, we're gonna focus on mainly knowing how to use the sine, cosine, and tangent because that is what's on our calculator. All right, so now let's go ahead and do one more example. Now we're gonna go ahead and solve triangle ABC below if capital A is 28 degrees and lowercase b is 15. Okay, so let's kind of let's kind of talk a little bit about what this problem means. It's telling us to solve a triangle. So solve triangle ABC. So whenever we see solve triangle ABC, or just in general solve the triangle, what that means is that it wants us to find all the missing information. So find all missing sides, and angles. Okay, so if I ask you to solve a triangle, that means that I'm giving you certain pieces of information, certain angles and sides, and I want you to find the other angles and sides, all of them. Okay. And so one more thing, notice how we have capital letters and we also have lowercase. In a triangle and just in any shape in general, when we think about capital letters, so our capital A, B, C, those are referring to the angles. Okay, so a capital letter is an angle. Hence right here, why A, capital A, is equal to 28 degrees. Okay, and that means that the lowercase letters, lowercase a, b, c, those are referring to the sides. Okay, and so also the same letter is always the same letter side is always across from its letter angle. So A and A go together, B and B go together, C and C go together. What does that mean? Well, if this is angle A, then this right here, straight across from it, is side A. If this is angle B here, then straight across from it is side B. If this is angle C, then straight across from it is side C. Okay, so that tells us one more piece of information about this triangle. This side over here is 15. Okay, B equals 15. And then I know that the angle up here, A, oops, I took out pieces of my triangle. There we go. We know that this angle is 28 degrees. Okay, so now we know 2 pieces of information about this triangle, which means that we need to go in and find 4 more pieces of information. Okay, now there was kind of one piece of information that we were given, just not told immediately. Notice how we have the box at angle C. So that means that angle C is 90 degrees. So we already know one piece of information right off the bat. Okay, C is 90 degrees. And then remember, because we need to find this last angle, angle B. How are we going to find that, do you think? Well, remember that the sum of angles in a triangle is 180 degrees. So what I can do is I can add up 28 and 90 and subtract from 180 to find the missing angle B. So add 28 degrees and 90 degrees, and that's going to give us 118 degrees. And then I subtract from 180. And so that's going to end up being 62 degrees. Okay, so just to kind of write it down, that way we know what to do here. So add known angles and subtract from 180. And that's how we found the missing angle. Okay, so we know angle B, I'll write it down here. Angle B is 62 degrees. Okay, so cool. We found 2 pieces of information so far. We found angle C and angle B. Now we need to find the remaining pieces, which is side A and side C. And you can kind of hopefully guess, based on our first example, we're going to use some trig to do that. Okay, now we have 2 known angles. We technically have 3, including this right angle at C. But remember, we usually don't set our theta on the right angle, just because it's kind of weird to think of it that way. Okay, because then our hypotenuse would become our opposite side at the same time, and that kind of just throws things off. So we're going to want to choose theta as either this 28 degrees or this 62 degrees. It actually doesn't matter which one we choose, as long as we choose one of them. Okay, let's go ahead and choose this 28 degrees to be our theta. So I'm going to say 28 degrees is theta. And so what I can do here is if I want to solve for C, first, I actually want to label my triangle. I'm getting a little bit ahead of myself. I want to label my triangle based off of where I put theta. So down here, this is my opposite side. That means this one would be our adjacent side. And then, of course, this is the hypotenuse. So if I want to find C, well, then I know my adjacent side, and I want to find my hypotenuse. So I need to find a trig function that involves the adjacent and the hypotenuse. Well, that happens to be cosine like in the previous example. So cosine of 28 degrees is equal to my adjacent side 15 divided by C. Okay, so here I need to do a little bit more algebra. I want to solve for C, so I need to multiply both sides by C so I can get it in the numerator. So I get C times cosine of 28 degrees is equal to 15. And the last thing I got to do is divide both sides by cosine of 28 degrees. Okay, so my C is going to be whatever I get from this. Let's go ahead and calculate that in decimals. So I have 15 divided by function's trig, cosine of 28 degrees. So I end up getting 16.99 is my measurement for C. Okay, so 16.99 is my measurement for C. Okay, and now I just need to find one more piece of information, which is my A. Okay, so I need to find A. And so I don't really want to use C in my calculations because if you remember, C was a really long decimal and I rounded it in my answer. So I probably don't want to avoid using this in my work. I still just want to use the one that was given to me, the 15. So what trig function relates the adjacent side 15 and the opposite side A, which is what I want to solve for? Well, if we look back up, opposite adjacent, that's going to be the tangent because tangent is opposite over adjacent. Tangent of 28 degrees is equal to opposite, so A divided by adjacent, which is 15. And so now here I just have to multiply the 15 over. I get A is 15, tangent of 28 degrees. And then I just have to do what I did last time and put that into decimals or into our calculator. So 15 times, so I'm just going to go ahead and grab the tangent function, 28. Here's my answer, 7.98. Okay, so A is 7.98. Okay, so we found all four answers. Whenever we solve a triangle like this, I want you to organize all your answers at the end, okay? So once you find all your missing sides and angles, I want you to put them all together in, just kind of in the same area. So what did I find? We found that B was 62 degrees, C was 90 degrees. We found that A was 7.98, and that C was 16.99. Doesn't matter what order you put them. I just kind of did them in this order. Doesn't matter if you kind of do angles and then sides or sides and angles are mixed, as long as you put all the answers you found in one location, okay, after you kind of did all your work to find them. All right, hopefully that sounds good to you guys. We're gonna do a little bit of practice with this on, the day that we do the practice for this. So I will see you next time, okay? Have a good rest of your day.